So first of all, just some quick rant. I'm not sure why I kept getting a 502 error at the beginning of the contest, which wastes some of my time. Also, I'm not sure why the last question is labeled as medium difficulty. I mean, only around 200 people were able to solve it, so making it even harder than many hard questions by that standard. So anyway, for the first question, the solution is straightforward. First, calculate the frequencies of all the words. Then, for each word, try reversing it and then check for a match. If there is one, decrease the frequency of both the word and its reverse counterpart of that word by 1 and increment the answer by 1 and eventually return the answer. For the second question, it can be solved using dynamic programming. We only need to focus on the remaining number of x, y, z, and the previously selected chosen string, which can be AA, BB, or AB. From there, we can consider every possible answer using recursion. For example, if the previously selected string is AA, we can only append BB after it. So we change the state to solve x, y minus 1, z, and BB. So of course, if we have used up all the BBs, it means y will be 0, so in that case, we cannot do y minus 1, so we simply just return 0 here. Notice if we previously ended at AB or BB, then they have the same options. Is that either can append AB or AA. We can group these two into one block, therefore. Lastly, just consider all 3 starting points and choose the maximum one to return as an answer. The third question can also be solved using dynamic programming. The only states we need to focus on are the current index, the starting character of the current string asked, and the ending character of the current string asked. So you might wonder why we only care about the first character of the current string. What about the second, third, or other characters in the string? So actually, we don't need to consider them because they will never be used when we join words I at the beginning. So it's because the characters the word I will be placed before S if we choose to join word I before S. Furthermore, each join operation will only erase at most one character. In the worst case, the word I is only one character long, and we just keep erasing the first character of S. Thus, the second character will never be considered, let alone the third or the fourth or the remaining of the characters. The same argument can also apply when we try to join the words at the end. Therefore, we only care about the last character, but not the second last or the third last or any characters before that. With that in mind, we can consider all possibilities from the current state. We can either put verse I at the beginning or at the end. Of course, if we have to change the start and end points for each state change, and subtract 1 if the character can be erased and 0 if they cannot. Finally, just begin the recursion by setting the start and end characters of the first word to obtain our answer. The fourth question is very challenging. I actually struggled a lot before coming up with an accepted solution. Actually, by the time I came up with the solution, it already passed the contest time, but I still managed to solve it. So anyway, the key is to think about when the computers are free, but not when they are occupied. So for example, if computer 1 accepts a call at the times 5 and 10, then the free intervals for computer 1 are from 0 to 4 and 11 to the infinity. So from there, we can calculate every free intervals for 4 computers. Now the answer just becomes calculating the overlap interval of each point in the query, so which is an easier program to solve. So that's all for all the questions. Thanks for watching.